Today we're going to review factoring again, just because we're going to be using it throughout Chapter 11, so sorry about that. I record these over lunch, so I get a lot of bells going on, but we really need to have a solid grasp of all the different kinds of factoring because it's going to be a huge step coming up in a lot of the sections in Chapter 11. So our objective today is we're just going to stop, we're going to go back to Chapter 8, and we're going to discuss and review the various factoring methods that we learned in Chapter 8, and we used a couple of them again in Chapter 9. So our objective when we're done is to just refresh our factoring skills from Chapter 8. So what I'd like to have you do here is in the note packet, make sure you're taking notes. I'm going to collect them again this chapter for points. So remember our number one thing that we do when we're factoring is, and it really helps, and especially in Chapter 11, we have to decide, is there anything that I can pull out? Is there a common factor or common term that I can divide out of everything to make it simpler? And actually in Chapter 11 we're going to be dividing it out because we're going to hope that it eventually cancels. So it's really important on here that you analyze each of these terms and say, is there anything that goes into 4x squared, 8x, and 12? And if there is, we're going to divide it out. So you should notice in here that there's a 4 that I can pull out of everything. So I'm going to divide every term by 4. I'm going to pull a 4 out, which is going to leave me x squared when I divide out of 4, plus 2x when I divide out of 4, plus 3. All right? And then what I have to do is I have to see if I can go any farther. And so what I have to do is I have to analyze this trinomial that's left here and see if there's any way I can factor that. So just a quick glance at the end, the only things that multiply to equal 3 are 3 and 1, and those don't add up to 2. So I know that that's as good as it gets. Sometimes the only thing you can do is pull out a common term. That's going to happen a lot in Chapter 11. Just for, and again, if it's in green, don't write it in your notes, but even something as simple as, say, this, you're going to have to pull out a 3. And then we're going to actually have a fraction, so maybe that's going to be over 6. And if you pull out that 3, you're going to be able to do some canceling. So we really need to recognize when there's a common term that can be factored out. So on the next one, again, we have to ask ourselves this question: can I factor out any common term? Well, you'll notice on number 2 that each one has an x in it. So what I'm going to do is factor out an x, or divide out an x. When I remove an x from x cubed, I get x squared. When I remove an x from 3x squared, I just have 3x. And when I divide an x out of 40x, I have 40. And again, just like up here, I need to see if I can go any farther. So a little quick analysis of this. I have to think of things that multiply to equal 40. And what pops into my head is maybe 2 and 20. Well, there's no way I can get a negative 3 out of those. And then maybe I try 4 and 10. That could give me 14s and 6s and negative 6s, but I couldn't get a 3. But when I take a look at 8 and 5, which multiply to equal 40, could I possibly get a negative 3 out? And you'd say, well, sure, as long as the 8 is negative. Run a little check on this pair of numbers. Do they multiply to equal negative 40? Yes, they do. At the same time, do they add up to the middle term, negative 3? Yes, they do. So we said in Chapter 8 that when that happens, when we can find that pair of numbers, we can factor it farther or unfoil it. So we know that we have to lead in x's. Oh, sorry, I should have written x equals. It's just x out front there. So I know I have to lead in x times x to get the x squared. I just said that my last terms are going to be 8 and 5. I need one positive and one negative, again with a sign analysis on there. If I have to multiply to equal negative 40, one of them's got to be negative. And we decided it was the 8 because we need to add up to negative 3. Remember, if you can check this by foiling. Let's just make sure we've got this one right. If I do firsts, I get x squared, score. Then I get outside plus 5x. Inside is a minus 8x, and those combine to my middle term. And my lasts, negative 8 times positive 5 is negative 40. So I know I have factored it or unfoiled it perfectly. So I want you to even write over here that you've got to remember how to unfoil or factor those trinomials. All right? So those were two of the kinds that we did in chapter 8. And let's move down a little bit here. Let's go look at number 3. Again, this first question I ask myself, is there anything that I can take out? Is there something in common between these terms? They both have a 7 in them, and they also both have an n in them. So when I factor out a 7 and an n, again, it's going to leave me a 2, there's my 14, and another n, there's my 14n squared. I'm going to need a minus. Now, when I have it all, I need to put a 1 right there. And again, I have to ask myself, am I done? And for this one, I am. There's no way I can break this down any farther. So that one's completely done. Let's move on to number 4. With number 4, can I pull anything out of both of these terms? The answer is no. And you might be tempted to say we're done, but remember in chapter 8, we said that if you have a binomial, 2 terms, and they're separated by subtraction, what you need to check is if both the first and the last are perfect squares. Because if they are, we have what's called a difference of squares. And those unfoil or factor very nicely. Remember, they factor into plus and minus. And what we used to say is that these lead terms are the same and these last terms are the same. We call them samers. So let's go take a look. I think I'll give you time to write that down for a second. So go ahead and write that down for the difference of squares. And again, had this been, so while you're writing it down, I'm going to talk a little bit. Had this 4 been a 5, then it's done. Because 5 isn't a perfect square. Had this been a plus, then it's done. Because it's not a difference of squares. And had this been a 3, it actually wouldn't be done because there's a common term that can be pulled out. So there's lots of stuff you got to keep your eyes out for when you're doing the factoring. But once I notice I've got perfect squares and perfect squares, I know it splits into sames out front. In this case, it'd be 2x and 2x. Sames out back. In this case, it'd be 3 and 3. And then we have 1 plus and 1 minus. And again, if I FOIL that, I'm going to have 4x squared, check. I'd have a minus 6x and a plus 6x, which cancels out. And then on my last terms, I'd have a minus 3. So I know that I've factored that perfectly. All right? So the next one, again, I've got another difference of squares. We're doing a lot of them because they're going to pop up quite a bit in chapter 11. The reason they pop, excuse me, my voice cracked. The reason they tend to appear quite often in chapter 11 is because they should be the quickest kind to factor. So let's notice we've got a difference. 49 is 7 times 7, 36 is 6 times 6. So I have a difference of squares. And so it factors into 1 plus and 1 minus, just like we wrote over here. And we have to make sure that they're the same term out front, which is why they need to be perfect squares, because we want that O and that I to cancel. 36 is 6 times 6. And I've just factored my difference of squares. And again, I could run a check. I'm going to do it. 49m squared, score! Minus 42m plus 42m, which means the m's are gone, which is why this is missing its middle term. And then lasts, I have minus 36. So remember, really what you're doing when you're factoring is you're breaking it apart. We break it apart by, number 1, can we find a common term? A lot of the times we can. If we can't, then we try to unfoil it, like we did on one of the ones up above. If we have a difference of squares, then we break it apart using our model for difference of squares, which is that we need to have a 1 plus and 1 minus to create a pair of opposites in the middle. We need to have the leads be the same, which is why they need to be perfect squares. Again, I want to repeat, had that been a 7, then it would be done. It would be unfactorable. We call that prime. Kind of like if I were to tell you to factor the number 19, you'd say I can't. except if I factored out a 1. So my last terms would be 5 times 5 to get the 25, and it's done. So what I'm going to do is I'm going to go to the next page where we've got a few more examples, and we're just going to work through a couple of them. I have a 15-minute time limit, so when we're done, I think I'll have Mr. Dorholt or Miss Dutzman or Miss Shiro just finish it up for you, and you make sure you pay attention and be good little people. So the next one says, how do I factor a trinomial when a equals 1? Let's talk about that. When a is equal to 1, remember we only need to worry about my last terms because I have to lead in x and x. Well, how about the ending? Well, I could have a 6 and a 1 or a 3 and a 2. And you might say, well, I can get a negative 5 out of both of those. And my answer to that would be yes, but this one would require 2 negatives, and that's not going to multiply to equal negative 6. So that's actually out. I need this combo. All right, we did those a lot. Same here. What multiplies to equal 16 and at the same time adds up to 8? Well, that would be x plus 4 times x plus 4. Remember, these can be checked by simply foiling what you did. First, x squared, outside 4x, inside 4x, last is 16, and it works out really nicely. Don't put all those foiling marks in your notes. So let's go to number 9 right here. We're looking for the factors of C that multiply, that add up to B. And maybe Ms. Shiro might want to pause this right here so you have time to write that out. So maybe do a little pause and then we'll come in here and do this one. What multiplies to equal 32? Well, 2 and 16 do. 32 and 1 do. 4 and 8 do, and that's about it. And remember, a sign analysis will tell me, because I need to kind of look at the signs right here. It says, how do you know what signs to use? Let the last term guide you. If it's a positive, it means I need negative, negative, or positive, positive. But then let the middle term guide you the rest of the way. So I know I need 2 negatives. Well, what's my pair that gives me the 18? There it is. So I'd have an n minus 2 and an n minus 16. And I know some of you have mastered this skill already, but we really need to pick it up for those who haven't. So next step, how do I factor a trinomial when a doesn't equal 1? And again, I'd like Ms. Shiro to maybe pause this so you can write that down. And then she'll start it up again. I only have 2 more minutes here of recording. So we factor the front and say, well, you would have to lead in 2x and 1x. That's my only options for leading, but how I pair them is going to be really important. So I can use a 3 and a 1 or a 6 and a 1. Well, I've got to figure out how I can multiply the outside and the inside and have it add up to a positive 1. So this is where we took our fingers and we tried to find the match. And we said, well, there it is. If I had a positive 2, it'd actually be a negative 2, and a positive 3, I could get these to add up to 1 and multiply to equal negative 6. So since I've linked this over here with the 1 and I want it to be negative, then I need to link this over here with a minus 1, which means on the inside right here, I'm going to, oops, I goofed this one up. That should be 3 and 2. Just a second. And I don't want to redo my recording. That should be a 3 and a 2. I'm going to start this one all over again. Just a second here. Sorry. So I had 2 and 1 and 3 and 2, and I'm trying to create that positive 1 in the middle. Can I do it? Or with a 6 and a 1. So again, I can do it if I can create a 4 and a 3, as the 3 is negative. So I've got my 2 that needs to be linked to a positive 2, and in the middle I need a minus 3. And again, I could FOIL it to check it. I have time for one more, and then someone else is going to have to finish the last one. So the only way I can lead is 3 and 1. The only way I can end is 1 and 5. Can I multiply and at the same time add up to 16? Sure, as long as I have 15 and 1, and they're both positive. So then when I lay this out, I say I'd have 3x and 1x. I'd like to put the 1 in there. Look at who I've linked the 3 to. It's linked to the 5. So outside here, I need my positive 5. And this would seem fast if we had learned it for the first time, but tell Ms. Shiro we worked on these for months. So we're just reviewing. So I'd like you to try this one, and then do it on your own, and we'll check and see if your answer's right. See ya!